complex number is a number that can be expressed in the form a plus bi. A and b are real numbers, and I is an imaginary unit. This equation is used to simplify, add, subtract, and multiply complex numbers. Types of complex numbers, such as real and imaginary. Real branches into rational and irrational. Rational numbers can be written as a fraction, such as 2, or -5, or 1/2. Irrational would be numbers like the square root of 2, pi, and the square root of 5. Imaginary numbers are things such as 2 plus 3i, or 4i, or just I by itself. When we add complex numbers, we do what we've always been taught to do, to just combine like terms. So 10 plus 7 would be 17, and -6i plus 4i would be -2i. So 17 minus 2i is our answer. It doesn't really matter what symbols are right here and right here, as long as the symbol right here is addition, we're just combining like terms to add them. So 3 plus 7 is 10, and I plus 2i is 3i. 10 plus 3i is our answer. Notice that now we have a negative in the middle. So first we have to distribute the negative to the 10 and the 4i. So 5 minus 2i minus 10 minus 4i. Then just combine like terms. So 5 minus 10 is -5. And -2 minus 4i is -6i. So -5 minus 6i is our answer. As long as there's a positive or negative between the parentheses, all you have to do is combine like terms. But since it's a negative, we have to first distribute it to the 1 and the 10i. So 8 minus 4i minus 1, and since it's negative times a negative, it is plus 10i. Then 8 minus 1 is 7, and -4 plus 10 is 6i. So 7 plus 6i is our answer. Now that there is no addition or subtraction sign between the number outside and the numbers inside the parentheses, we'll have to distribute the 2i to the numbers inside the parentheses. Now, before we get into this equation, we have to know that I squared is equal to -1, and we'll end up plugging that into the equation later. So, 2i times -4i is -8i, and 2i times 3i is 6i squared. Now we learned earlier that I squared is -1, we plug it in. So -8i plus 6 times -1. So it's just -6 minus 8i, or -8i minus 6. Again, since there's no number between the parentheses, we have to distribute the numbers inside the parentheses to the next set of parentheses. So 6 times 2 is 12, and 6 times 3i is 18i. And then -4i times 2 is -8i, and -4i times 3i is -12i squared. Then we plug in the -1, and we get 12 plus 18i minus 8i plus 12, because it has multiplied by -1. So then we get 24 plus 10i as our answer, because we combine like terms. Now we have to learn the complex conjugate. This is a really simple thing, which is basically the inverse of it, where you just flip the sign in between the two numbers. So, if we're given -5 plus 6i, the inverse would just be this flipped. So -5 minus 6i. So this is the complex conjugate. Just one more to make sure we got it. If you're ever asked for the complex conjugate, just flip the number in between the real number and the imaginary number. So it would be 2 plus 1/2i as our complex conjugate. Now on to simplifying radicals. So there's an understood 2 here, and since 72 is not a perfect square, we're going to be breaking it up and taking out groups of 2 outside of the radical to simplify it. So 72 breaks up into 9 times 8, and that breaks up into 3 times 3 times 2 times 2 times 2. Now, we have a group of 3's and a group of 2's, and so left over will be a 2 under the radical. So we take 3 and 2 outside the radical and leave 2. And 3 times 2 is 6. So 6 square root 2 is our answer for simplifying radicals. Now on to the square root of 50. So that breaks up into 2 times 25. This can be further broken up into 2 times 5 times 5. We have a group of 5s, so we take 5 outside the parentheses, and left over is 2. And that's our answer. Now, for 110, we break up into 10 times 11, which is 5 times 2 times 11. And you'll notice that there are no groups, which means the square root of 110 is a simplified version. It cannot be simplified any further. Now I'll just do 2 more to make sure we grasp this concept, because we'll be applying it to other types of functions later. So this can be broken up into 4 times 20, which is 2 times 2 times 2 times 10. This can further be broken up to 2 times 2 times 2 times 2 times 5. Now we have 2 groups of 2's, so 2 times 2 square root 5. So then we have 4 square root 5 as our answer. And for square root of 48, we have 6 times 8, which is 2 times 3 times 2 times 2 times 2. And so we have a group of 2's and a group of 2's. So we have 2 times 2 and a leftover 3. So 4 square root 3 is our answer for the square root of 48. Now that we've taken the square root of normal radicals, we can take the square root of negative numbers. We've always thought that you can't take the square root of a negative number, but now we can just take it out in the form of an I. So it's an imaginary number. So we have to take the negative out in the form of an I. So it becomes I square root 9. And we'll multiply I times the square root of 9, which is 3. So then it becomes I times 3. So then 3 times I is just 3I. So 3I is our answer for the square root of negative 9. For negative 27, it becomes I square root 27, which becomes I square root 9 times 3, which is 3 times 3 times 3. Take those outside the square root symbol. So we have 3 square root 3, and it's I times that. So it's 3I square root 3 as our answer. Now that we've simplified radicals, we can apply it to these square root functions. So we're going to solve for x by taking the square root. So it becomes x squared is equal to 36, because we added 36 to cancel it out. And so then we have to take the square root. And remember, since it can be imaginary or real, you have to have a plus or minus symbol in here. So then we take the square root, it becomes x is equal to plus or minus 6. So our answers are x is equal to 6 and x is equal to negative 6. For our next one, we add 625 to cancel it out. So x squared is equal to 625. And the square root of 625 is 25. So if you take the square root, it becomes x equal to plus or minus the square root of 25. So that's our answer. It can be written as that, or you can write it out as x is equal to 25 and x is equal to negative 25. So yes. So since there's a 2 in front, we should take out the GCF. So if we divide by 2, we get x squared minus 60 is equal to 0. So then we get x squared is equal to 60. And now we have to take the square root of 60. So that's 6 times 10, which is 2 times 3 times 2 times 5. And group of 2's, so 2 square root 3 times 5, so it is 2 square root 15. So then we take the square root of this, and so x is equal to plus or minus 2 square root 15. And now this is an imaginary answer, but it is our answer. For our last one, we have to take out the GCF again. So negative 10, so that cancels out. We get x squared minus 6 is equal to 0. So x squared is equal to 6. And so, the square root of 6. And so we have to take the square root of both sides. And so we get x is equal to plus or minus the square root of 6. Because if if we try to take the square root of 6, we just get 2 times 3. And so this is our simplified answer. So that's the end of complex numbers. If you'll remember, we just added, subtracted, multiplied, and took the square root of complex numbers. And so that's what we reviewed in this lesson.